So here's a quick introduction to spectroscopy, and then the first of our analytical techniques, index of hydrogen deficiency. So spectroscopy, the idea here is just that we're analyzing molecules, compounds, to figure out what is there. We've spent a lot of time learning how to name things, learning how to identify functional groups. Now we're going to look at how do we even know that those functional groups are on the molecules that we're talking about. The first thing that we can do to analyze what functional groups are in a molecule is by determining index of hydrogen deficiency, or the degree of unsaturation. And this just helps us know if there are double, triple bonds, if there are rings in a molecule or not. So here I can count and I can see that there are 6 total hydrogens. Here I've only got 4, and now we're down to 2. So every time I go from a single bond to a double bond and then to a triple bond, we lose some of those hydrogens. The molecules become more hydrogen deficient. This is all we're looking at, is how many hydrogens has the molecule lost because of rings and or double and triple bonds. So these degrees of unsaturation, you do need to memorize these. A double bond is going to have a degree of 1, triple bonds each get 2, and rings are 1. So when I look at this molecule of benzene, I see that it's 1 ring plus 1, 2, 3, 1, 2, 3 double bonds that each have a degree of unsaturation of 1. So 1 ring plus 3 double bonds gives a total IHD, or index of hydrogen deficiency, of 4. Look at this guy, he's got 1 double bond. That's all he's got. His hydrogen deficiency index is just 1. 1, 2 double bonds, index of 2. Getting a little bit trickier here. I've got 1 ring, 2 rings. And then we've got 1, 2, 3 triple bonds. Sorry, those are double bonds. 3 double bonds. And so our total hydrogen deficiency index will be 5. Here, I've got 1 ring. I've got 1, 2, 3, 4, 5 double bonds. 5 double bonds plus 1 ring is a total index of hydrogen deficiency equal to 6. So we can look at the structural formula of a molecule and figure out what its index of hydrogen deficiency is. We also have this formula that you could memorize, and I don't know why you would want to do that, but you can. So this is our formula for determining index of hydrogen deficiency. I'm going to take 1/2 the number of 2 times the carbons plus 2 minus the number of hydrogens minus the number of halogens plus the number of nitrogens. So all the carbons times 2 plus 2 minus the number of hydrogens minus the number of halogens plus the number of nitrogens. So look at this guy. Index of hydrogen deficiency is going to be 1/2 of 2 times the carbons are 4 plus 2 minus the number of hydrogens is 8 minus the number of halogens, there are none, plus the number of nitrogens, there are none. So then 1/2 of 8 plus 2 minus 8 is 1/2 of 2. The index of hydrogen deficiency for this molecule is 1. Good? Good. So how this would look on a test, here's a question, index of hydrogen deficiency of 3-methylcyclohexene. We would count that 1 ring, there's 1, 1 double bond, there's 1. So the total IHD is going to be 2. Easy peasy.